In lesson 6.4, we are going to talk about special parallelograms. And special parallelograms being the rectangle, the rhombus, and the square. Now, these figures will have all of the properties of our parallelogram that we talked about in lesson 6.2 and 6.3. Opposite sides are parallel and congruent. The opposite angles are congruent. Consecutive angles are supplementary, and that the diagonals bisect each other. But because they are special parallelograms, there is additional information that is true. The first one, the rectangle. We know what a rectangle looks like, but what is the definition? Well, the definition says it is a parallelogram with 4 right angles. And so in order to be a rectangle, we need to have 4 90-degree angles. Because we have 4 right angles, it just so happens that not only do my diagonals bisect each other, but my diagonals end up being congruent. So over here in my picture, my diagonals congruent means that these 4 segments are going to all be equal. And you'll notice here then that I have divided my rectangle into 4 triangles. They're not all of the same, they're not all congruent, but I do have isosceles triangles. Also, because I have a rectangle, when I put in one diagonal, I end up having a right triangle. And sometimes finding some missing side length measures, we're going to end up using the Pythagorean theorem. Looking down below, my quadrilateral, JKLM, in both examples 1 and 2, is telling me it is a rectangle. The first one, 2x plus 4, my angle right here, and 7x plus 5, this angle here. Now I'm wondering about finding my value for x. Do those 2 angles equal? No, they do not equal. Those do not bisect the angles. However, because a rectangle is a parallelogram, I can think about alternate interior angles. And 2x plus 4, alternate interior, would be equal right down here. And what do we know about this angle here at L? Yes, it should be 90 degrees. And so I know that I can take my 2x plus 4 plus the 7x plus 5, and that should equal 90 degrees. Combining like terms, solving for x. What would that tell me? Well, x is 9, which would make this angle 22 degrees. This angle would be 22 degrees. And we could easily find this by subtracting from 90. I will also point out that because these diagonals are congruent, that angle would be 22 as well. I have an isosceles triangle. Looking at number 2, I'm looking to find my value for y. And here, I'm not looking for an angle measure, but rather I'm looking for a side length, or the length in my diagonals. Well, because my diagonals bisect each other, and they are congruent, these 2 sections are going to be equal to each other. They are going to have the same length. And so I'm going to set 3y plus 5 equal to 5y plus 1, and solve. Subtracting 1 from both sides, subtracting 3y from both sides, I end up finding that y is 2. If y is 2, that tells me this part of my diagonal is 11, which would mean the whole thing would have a length of 22. The second special parallelogram that we're going to talk about is the rhombus. And a rhombus is simply a parallelogram with 4 congruent sides. 4 congruent sides. Well, because my 4 sides are the same, there's something that's true about my diagonals. Now, my diagonals are not necessarily the same length. You can see up here that if I would sketch in from F to H and from G to J, that one diagonal is clearly longer than the other. However, the thing that is true is that they meet at 90 degrees. And so the diagonals of my rhombus are going to be perpendicular. Now my diagonals also still bisect each other. And so if we would know this length to be 4, this would be 4, but this diagonal is just a little bit longer. I see here I have some right triangles, and so again, I may be using some Pythagorean theorem when I solve some questions asking about my rhombus. Not only do the diagonals meet at 90 degrees, but they also bisect the angles. Bisecting the angles. Therefore, if you take a look, if I told you that angle 1 was 25 degrees, because it bisects my angle, I also know 2 would be 25 degrees. But this is a parallelogram. Opposite angles are congruent, and so my angles 3 and 4 would also have to be 25 degrees. Now what about angles 5, 6, 7, and 8? Are they going to be 25 degrees? No, they are not. In fact, if parallelogram, we said my consecutive have to add to 180. Well, if this is a 50-degree angle, this angle here would be 130. Half of 130 would tell me these would be 65. Looking down below, my figure TVWX is a rhombus. Now I'm going to take a look at solving first for TV. Well, TV is a side length. If I know I have a rhombus, I actually know that all of my sides are congruent. And so I don't have any information about this side TV or my side WX, but I can see the top and the bottom, 3b plus 4 and 13b minus 9. Well, I can set those equal to each other to solve for a value of b. Just so happens that b comes out as 1.3, and that would give me the side length for the top or the bottom. I'm going to take that, I can plug that back in. What's true though, if I find this value, it's going to be congruent to side TV. So if we take 13 times 1.3 minus 9, we end up finding that we get 7.9. So I can go ahead and say that TV would be 7.9. Taking a look at number 2, they're wanting me to find an angle measure. My measure of angle, VTZ. Now I first want to take my pencil or pen and I want to find that angle, VTZ. If I outline it, I can see here that I'm talking about this angle right in here. Well, because the diagonals bisect, at first glance I see, well, VTZ would be equal to 5a minus 5. 5a minus 5 equal to 5a minus 5, though, is not going to give me a value for a. So I have to think about, okay, well, what do I know about a? I see here 14a plus 20 is pointing into the middle. I know the diagonals of the rhombus meet at 90 degrees. So I'm going to take that 14a minus 20 and think about equaling that to 90. Which would mean that 14a would equal 70. Divide both sides, or a would equal 5. If a equals 5, I'm going to go ahead and substitute that in to find my value. 5 times 5 minus 5 is going to tell me that my angle, my measure of angle VTZ must equal 20 degrees. Now if this is 20 and 20, these would also be 20 and 20. And we would be able to then tell if this is a 40-degree angle, this angle up here would have to be 140. Finally, let's have a little bit of discussion about a square. is a special parallelogram, and it is special because it is actually considered a rhombus and a rectangle. A square has 4 congruent angles, which are 90 degrees, and 4 congruent sides. Therefore, it makes it a rectangle and a rhombus. All of the properties would be true for a square. Example C is wanting me to show or to prove some of those properties about the diagonals. It says, show that the diagonals of square EFGH are congruent perpendicular bisectors of each other. My diagonals, FH, EG. Those are my 2 diagonals, my 2 purple lines. I'm really wanting to show congruent perpendicular bisectors. I'm going to break that up a little bit. Actually, I'm going to break that into 3 parts. The first part, we're going to ask ourselves, well, how would I prove that my 2 lines are congruent? What do we have in our math toolbox that would allow us to do that? Well, proving 2 lines or segments congruent, we can go ahead and find or talk about the length, which would mean that we are going to use our distance formula. So first I'm going to talk about or think about my segment FH and the distance formula, setting up like so. For FH, that means I'm going to be using my coordinates of F and my coordinates of H. My distance formula says x minus x quantity squared plus y minus y quantity squared. So I'm going to take negative 1 minus 0 and 3 minus negative 4. Now you could punch that into your calculator, but because these numbers are fairly small, it might be just faster for us to do this mentally. Negative 1 squared is going to give me a 1. 7 squared is going to give me 49. So this tells me that this has a length of the square root of 50, which is probably about 7.1. Now I need to check my other diagonal. Well, my other diagonal would be EG. So I'm going to go ahead and use my coordinates from point E and point G. Again, I'm going to set it up the same way. X minus x, quantity squared, and y minus y, quantity squared. I'm going to simplify. I would have a negative 7. Negative 7, but I'm going to square it, and we'd end up with positive 49, and a negative 1 squared. And I can see I'm also going to end up with the square root of 50. This tells me the 2 segments are congruent. They have the same length. Secondly, I want to think about, well, how would I prove that my diagonals are perpendicular? We talked about in semester 1, perpendicular lines, there's something special about the slopes. Perpendicular lines, the slopes are opposite reciprocals. So we're going to take a look at finding my slope for FH and finding my slope for EG. Slope, we know slope to be y minus y over x minus x. So again, I'm going to go back to using these coordinates, F and H, y minus y, x minus x. I'm going to simplify that down. Now I'm going to find my slope for EG. Same steps, y minus y over x minus x. Negative 1 over negative 7 is going to give me positive. Now is this okay? A negative 7 and a positive 1, 7? Yes, because those are opposite reciprocals. So that's going to show that my 2 lines are perpendicular. Lastly, I want to take a look at showing their bisectors. If they bisect each other, they cut each other in half. But what do we have in our math toolbox to show they would be they would be bisectors of each other? Well, they're going to have the same middle. In other words, they should have the same midpoint. So in my step number 3, I'm going to think about showing midpoint for both FH and EG. And those midpoints should come out the same. Now my midpoint is my middle, so when I take a look at F and H, I'm going to think about averaging my x's and averaging my y's. So for midpoint, I'm going to take -1 plus 0 divided by 2, and 3 plus -4 divided by 2. Now this is a coordinate point, so I should come up with an x coordinate and a y coordinate. I'm going to simplify a little bit. So I come up with FH as having a midpoint as -half, and now I'm going to check EG. X plus x divided by 2, y plus y divided by 2. And you can see we have shown both -half as our midpoint. And in fact, if we come up here to our graph and we go -half, we can see that that is our intersection point. So now we have shown they have the same midpoint. And that is how I would show in three steps our congruent perpendicular bisectors of each other. Now, as I said before, since a square is a parallelogram, a rectangle, and a rhombus, all of those properties are true for a square. And if you kind of wanted to think about a little bit of a family tree here, we have our parallelogram, all these properties to be true, and we said that one of our special parallelograms is our rectangle. Well, to be a rectangle, we said by definition, we need to have 4 right angles. Our rhombus was another special parallelogram, and to be a rhombus, we need 4 congruent sides. A square, we need both 4 right angles and congruent sides. So how does that fit in? Well, if we put our square down here, congruent sides, right angles, it is a rectangle and it is a rhombus. And so that's kind of how our family tree for those would fit together. If you have more questions on this, our special parallelograms, please stop in and see me.